All right, so your test is also going to include some trig functions, right? So if you don't understand the theory behind trig, I suggest you go through that in detail, right? If you don't, this is just a hint of what you can do, right? So if you have your calculator, right, specifically a Casio, right? I'm not sure if you can do this on Sharps. I've never, okay, so a Casio, and usually it's the A2ZA plus, right? Put your calculator into table mode, okay? How you do that, you press mode. Okay, select mode. It's next to the on button, and then you select the option with the table. So option 3. Okay, press that. Once you do that, the screen on the calculator will say fx equals, right? Now, if they ask you to sketch a particular graph, right? Let's say they say sketch the graph of f of x equals sine x. And let's say you don't know, okay, what it looks like, okay? You're gonna plug in sine x or type in sine x by using the actual sine function, right? And then alpha to select your x. And remember, the x is above the curved bracket, okay? Then close your bracket. You press equals. Okay. Once you've done that, you'll get something that says g of x. We're not going to type in anything there. Leave this part blank. Okay. Just press equals. Your start point. Now, in the sketching of the graph, they'll tell you what the restriction is going to be, or from where to sketch it. So they'll write it as either x is between 0 and 360 degrees, or they could write it as from negative 180, right, to 180 degrees. Now, this is what you're going to use for your start and your stop, or start and end points. Your start points, based on these restrictions, either negative 180 or 0, okay, depending on what the question is asking you. For this one that I want us all to sketch together, we're going to make our start equal to 0, okay? So write 0. So you just press 0 equals. Then your end point, okay, is where your 360 is. So end is 360, okay? Now your step, okay, we're going to make our step 45 degrees. We can even make it 60 degrees, okay? Again, depending on whether they give you graph paper or not. On the graph paper, sometimes they will actually show you what the step is going to be. So if they give you a graph that looks like this, they'll give you 0 to 360. You'll read that off your graph. Then there'll be intervals. Use those intervals they give you on your graph paper and make that your step. So for today, let's put 45 degrees. Okay, so your step is 45. Then you press equals, right? Now you're gonna get a table. Okay, so there's some noise. Okay, that's better. All right. So your step, we've selected 45, right? And we want to sketch the sine x graph. So now on the table, you're going to have x and then your f of x. Your x, this is going to be your values that you're going to put on your x-axis, right? You'll see it goes all the way up to 360, okay? And obviously you're only doing this if you're completely stuck and you don't know what the shape of your graph is. Otherwise, you're going to take way too long, okay? So you do this till you get to 360. Okay, and now the y values are going to give you the general shape of the graph. So when x is 0, your f of x is 0. Then 0, 7, 0, 7, 1. Then at 90, it's 1. And then it starts going back down. 135, 0, 7, 0, 7, 1. 0, negative 0, 7, 0, 7, 1. Negative 1, it starts going back up. Now, as you can see, these points are going to give you the general shape. So you can use these points to now plot your graph from 0 to 360. Your graph is going to look something like that. Okay, remember, you only do this if you don't know what the shape of the graph is going to be. Okay, so you can plug in whatever graph or equation they give you. So if it was f of x is equal to cos x, okay, you would plug that in as well. Same thing for tan x, okay. You would do the same process. You get your table of coordinates and then use those points to plot. Now, there are particular points that we're looking for when you're sketching. Your start point, which is your 0, 0, okay, and here your end point, which is 0 and 360 degrees. Okay, this point here again, this is 180 degrees and 0. This maximum point here, 90 degrees and 1. This one is 270 degrees and negative 1. Okay, so from the table, I've sketched my graph. I've marked off the turning points. So the turning points, that's the 90 and 1 and the 270. You've got the correct shape and you've got all the intercepts, right? So for doing that, you get a mark for the shape. Then you get a mark for the intercepts, okay? Then you get a mark for the turning points. Okay, so between 3 and 4 marks for a sketch like that. All right. Any questions regarding the sketching? Okay, so I'm assuming you all understand this. All right. Now, going back to the theory. So looking at this graph, what would our domain of this graph be? What would the domain be? What would the range be? Okay, remember your domain relates to the x values. So there's several ways of writing the domain. So for this particular graph, it's going from 0 up to 360 degrees. The range for this graph, look at the maximum. The maximum value is 1. The minimum value is negative 1. So your range is between negative 1 and 1. Okay. Now, what is the period of the graph? Okay, the period relates to the after how long does the graph repeat its wavelength. Okay, so for sine and cos, the periods are always going to be 360. Okay. Then for tan, the period, tan x, the period is 180. Okay. Then we have what we call amplitude. Amplitude, this is the height from the middle of the graph, height from middle to top. Okay. So for this particular graph, if we look at the middle of the graph to the top, what's the amplitude for this one? So from the middle to the top, that would be 1. Another way of working this out would be a half of the maximum value minus the minimum value. Okay, so for this one, half of the max value was 1. Your minimum value is negative 1. So 1 plus 1, that gives us 2. Half of 2 is equal to 1. Okay, That's how you work out the amplitude. Okay. All right. So basic theory that we just went through. So now we're going to look at particular questions. Okay. So like I said, for sketching, if you're stuck and you don't know the shape, you just plug it into your calculator and sketch. Let's look at this first question that we have here. Okay. The diagram below represents graphs of the functions f of x equals a cos x and g of x is sine x plus q. Okay, so we've just sketched out a sine x graph, right? Now, the one that they have here, there's something that's happened to the sine x graph, okay? Originally, what was your sine graph? It looked like that. The maximum was at 1. The minimum was at -1. Look at the one they have here. The new maximum is at 2. And the minimum is at 0. Okay, so we're going to use that to figure out what this Q value is. Right? So what have they done to this graph, your original sine x graph, to get it to this one here? What type of a translation would that be? Any ideas? Yeah.
Ma'am,
Yes, darling.
They moved it up by 1 unit.
Brilliant, right. So your Q value here is 1, and the translation is they've translated the graph 1 unit up. Brilliant, thank you. Now, let's work out what our A is in this cos x, okay? So let's see. So you have the function f of x is equal to a cos x. I need to work out what this a value is. Remember where f of x is, another way of rewriting that is y equals a cos of x. Any ideas what I can do to work out what the a value is? Okay, so let's look at our graph, right? Looking at the graph, they've given us particular points for the a cos x, okay? They've given us the first point here. When x is 0, the y value is 1. They've also given us when x is 90, the y value is 0. So we have 90 and 0. We have 0 and 1. We also have 180 and -1. We've got 270 and 0. And we have 360 and 1. What can I do with those values to work out what A is? I can sub in any of those values, sub any of the points you have, okay, into that equation, okay? Because you have an X value here, you have a Y value there, okay? So let's go ahead and do that. If I take the first point, oh, sorry, I'm trying to erase this. If I take the first point, which is 0 and 1, and sub it into the equation. So when y is 1, a cos 0, like that. So I subbed in the first point, 0 and 1. Let's see. When cos is 0, okay, now you'd have to clear your calculator so that you get back to normal computer mode on your calculator. Cos 0, we all know, well, we should all know that it's equal to 1. Okay, now you've got a times 1 here is equal to 1. I want to make a the subject of my formula. So that means I'm going to divide both sides by 1. So we've just proved or shown that a is equal to 1. I could have also subbed any of the other points. Let's sub 90 degrees and 0 into that. Okay. Again, y here was 0. A Then here you have cos 90. Okay, so now this one's going to be a little bit different, right? So cos 90, that gives us 0. Okay, so that one's not going to work. Let's try another one, 180 and 180 and negative 1. Okay, plugging in that point, 180 and negative 1. So negative 1 equals a cos 180. So cos 180 gives us negative 1. So a multiplied by negative 1 is equal to negative 1. You want to make a the subject of the formula. You divide both sides by negative 1. That again leads us to the same answer, that a is equal to 1. All right. So that's how we do the first one. So again, for question 1, a is equal to 1. What's the range of G? Okay, range, remember, relates to which values?
Y values.
Right. So looking at the graph they've given us here, I'll erase the unnecessary stuff. What would the range be for G? So range, you're basically looking at your maximum and your minimum. What's your range for this particular graph?
Ma'am, would it be 0 is greater, or yeah, 0 is greater than or no less than or equal to x, which is less than or equal to 2.
Okay, awesome. So your range, like that. Brilliant. Good. That's how you work it out. So I'm not sure, other teachers may have taught you to write it like this as well, from 0 to 2. So either of these would suffice. Okay. That would be your range. Now, this question here. We're looking for the point where g of x minus f of x is equal to 2. Remember, these are y values. So we're looking for the difference between the two y values or the two graphs. Okay, the distance between the two graphs should be equal to 2. Okay, let me zoom in so you guys can see clearer. So looking at this particular graph, at which points can you see a distance of 2 between the two graphs? So you're looking at the y values. Okay, so this first one here, let me highlight it. So that's your G graph. And you have your F graph. Where is there a distance of 2 between them? Okay, so I'm gonna show you the first one, which is the easier one. Look, the distance between these 2 points here. Okay, that's 2. How did we get that? Okay, at this particular point, can you see that the G graph, okay, the y value of G at this point here is 2. Then the y value of F at this point is 0. So 2 minus 0. 2 minus 0 gives us 2. Okay, so at which x value is that? It's at 90.
90.
Brilliant. Okay, now, is there another point on this graph or along these two graphs where you're going to get a difference of 2 between them?
180 degrees, ma'am.
Brilliant. Well done, Afif. Okay, so at this point here, I'm going to highlight it for you here. Okay, how did we get that? We went and we looked at, okay, what's the y value of G at this point? It's 1. What's the y value here? It is negative 1. So let's subtract 1 minus 1. That gives us 2. And what's that x value? It's at 180. So the two values, 90 degrees, second one, 180. Well done. Awesome. Then reflections now. Okay, the reflection of f of x in the x-axis. Remember, we did reflection some time ago. How do we reflect something in the x-axis? Who remembers? So a reflection in the x-axis. Okay, so if you're stuck or if you weren't here last time, right? If we reflect something in the x-axis, let me take this point here. If this point is 1, 1, and I reflect it in the x-axis, which is this horizontal line here, what would the new point be? The x wouldn't change. 1.
-1.
Brilliant. Thanks, Afif. So 1 and -1. So what's happened to your x value has stayed the same, but what's happened to your y value? It's become negative.
By -1.
Brilliant. So to reflect anything in the x-axis, we always multiply the entire graph by -1. All right. So your f of x, what was it originally? It was a cos x. So y equals cos x, because remember we worked out that the a is 1. So reflect this in the x-axis. All you have to do is multiply that, okay, by -1. So the new equation is negative cos x. Okay, so we've answered 5.5.1. Now, g of x. Okay, what was the equation for g of x? The original equation for g of x was sine x plus 1. Okay, sine x plus 1. Now they want you to shift it down how many units? 2 units. So what does that mean? What should we do at this point?
-2.
Perfect. We're going to subtract 2. Okay, so plus 1 and minus 2 here to perform the translation. So your new graph is going to be sine x minus
-1.
Brilliant. Okay, so this is the new equation. Awesome. Brilliant. Okay, so we've done the first one. Let's go on to the second type of question. Okay. So this was taken from one of your past papers. I'm going to try and zoom out. Okay, so the graphs of f of x, a sine x, and g of x cos x plus 1. They've given you the domain as x is between 0 and 360, and it's sketched below. Okay, so this one here, this g here, this is the cos x plus 1. Okay, and then this one is your f of x is equal to a sine x. Okay, let's write down the value of a, then write down the period and range. Okay, so value of a. Okay, what did we say we do to work out what that a value is? We said, okay, let's go and look at what values we have for this sine x, right? We've got this first value, which is 0 and 0, right? Then we have this one, which is 90 and 1. Then this one, which is 180 and 0, 2, oh, sorry, this is 2 here, 270 and -2, and 360 and 0. Okay, to work out what a is, right? You can sub in any of those points, okay? 0, 0 won't work, okay? So we're not going to try that one. Let's sub in 90 and 2. So your x value is 90 and your y value is 2. So 2 equals a sine 90. Sine 90 we know is 1. So you end up with your a being equal to 2. Okay. Write down the period of f. Remember, period refers to the wavelength or after how many degrees your graph starts repeating. So period of f, which one is f? F is this one. So what's the period for this one?
360.
Well done, 360. Okay, we've worked out that. Range of G. G is the one I'm going to highlight now. This is G. Okay, how do you work out the range? Okay, range, remember, it's your Y values, and they go from what to what for this particular graph.
0 to 2.
Brilliant. Then now, this is a slightly complicated type of inequality. What this means, for which values of x will f of x multiplied by g of x be greater than or equal to 0? Let's understand this part, okay? Greater than or equal to 0. What type of values are those? Those are positive values. So we're looking to see if I were to multiply the two y values of the two graphs, where will I get positive values, okay, and along the x-axis? Okay, so let's look at the y values of each of these graphs, okay? So for the one in blue, okay, all the y values are positive, okay, except when it's at 180, because that is now 0. So, but along the rest of the graph, they're all positive. Then for the yellow graph, they're positive up until they get to 180. Then can you see they start becoming negative
Negative.
up until there. Now, what are the ways of getting a positive value? Either you multiply a positive with a positive value, or you multiply a negative.
And negative.
Right. Now, for this one, let's look and see where if I multiply a positive value on the F with a positive value on the G, I'll get a positive. So up until which point will that happen? It's from which point to which point? Yes, you're right. Say it louder.
0 to 180.
Good. From 0 to 180. Okay, this is the first period where you will get a positive multiplied by a positive. So it's this value multiplied with this one. Okay, all the way up until you get to 180. So that's our first point. Now, it's important because there was no equal sign here. So the first interval, okay, is between 0 to 180. Okay, that's the first point. Which is there any other point here? Look, so now if you come this side, this is a negative multiplied by a positive. Are you going to get a positive value if you multiply a positive and negative?
No.
No, right? So everything on the other side is not going to be valid. So your answer is that. Well done. Okay. Now, 5.5, the graph of G is reflected about the x-axis. Okay, so which one was G? G was cos x plus 1. So cos x plus 1, they're reflecting it about the x-axis. What did we say about reflections on the x-axis? We have to?
Minus.
So we multiply the entire graph by negative 1. Okay, so when you do that, right, remember we want to get the new h. So h, so now so far, okay, with the reflection, it's going to be negative cos x minus 1. Because what did you do? You multiplied this whole thing by negative 1. So the signs change. Then they say they want to translate it up 2 units. So what should I do after this? If I want to translate it up 2 units, I should
Add 2.
Perfect. So h of x, the final equation is negative cos x and +1. There we go. Done. That's your 5.5. Well done, guys. Good lesson.